Yes, today I want to talk to you about Chapter 7, Section 7.1 and 7.2. This is for you guys to watch while I am out the week of February 13th. I believe you have the notes for this, but in case you do not, I will be sending those out in email as well. So let's go ahead and get started. So Chapter 7 is Chapter 6 was all about fractions. Chapter 7 is called applying fractions. So we're actually going to use fractions to do different problems. All right, so the first lesson, 7.1, is all about ratios. So I wanted to take a look at the notes here. Ratios are basically comparing two numbers to each other. And there is, let me print screen this. There's three different ways that we typically see ratios written. Okay, so if I compared, let's think in our Algebra I class, right? We have 3 ladies and 2 guys. All right, so three guys. No, 2 guys. Sorry about that, guys. And we have 3 ladies, right? So if I wanted to write a ratio of guys to girls, I would say that we have, for every 2 guys in our class, we have 3 girls. Okay, and I didn't write that very well, but it looks like the little, the colon that you have on your clock. This would be the ratio of guys to girls. It's a common way that you see ratios written. And it's written right here using a colon. All right. Another way we could say 2 guys to 3 girls would be 2 to 3. So these are definitely the 2 most common ways that we see ratios written. There is a third way, which would be 2. So we're going in this order here. That one's kind of the least used option, okay? So if we have 2 guys, 3 ladies, we could say the ratio of guys to girls is 2 to 3. The ratio of guys to girls is 2 to 3. Or like say, for example, we want to say what is the ratio of guys to people. All right. So in our class, we have 5 people and 2 guys. So that ratio will be 2 to 5 or 2 to 5. We read them the same way. We use the word 2, so 2 to 5 when we're reading them. And yeah, so that's what we want to do with that. All right, so let me show you a couple examples of ratios. We have them written out right here. Oops, didn't mean to do that. Okay, so if you have on your paper, we have write each ratio in simplest form. And I know it's written out here for you, but for example, if you had, well, let me pick a different one. If I had 60x, that's my ratio. So whatever it is, my ratio is 60x to 30x. And I want to write this in my simplest form. Well, what we want to do is we want to use the fraction version of our ratio to y. So we can also say this is 60x to 30x. Okay, and now we can do some simplifying, right? When we know how to simplify fractions, because that's what we spent all of chapter 6 doing. So the x's actually cancel out, and 30 goes into 60. Now this is kind of a little weird, but don't forget that there's a 1 down here in the denominator, right? When we don't have anything written. So we could say that 60x to 30x, another way we could write that is it's a ratio of 2 to 1 or a ratio of 2 to 1. Okay, and I switched it up a little bit from this example. Yeah, so that is that. So let's scroll down to a couple examples in your notes. Here we go. Over here. Okay, so, oops. There we go. Example number 1, we have 28x to 21x. So what we want to do is to simplify this ratio in the simplest form. So I like to simplify using fractions because we're used to fractions, right? 28x to 21x. These are the same ratio. We say it the same way, but they're just written in different formats. Now we should be able to cross off our x's, right? Because we have an x and an x. And 21 and 28 have a common a number in common. They both are factors of 7, right? 7 goes into 21 3 times, and 7 goes into 28 4 times. So we can say that this is a ratio of 4 to 3, or we could say it's a ratio of 4 to 3. Either way would be acceptable. All right. Number 2, we have this ratio is already written in a fraction form. So 63 r squared s squared to 81 r s to the fourth. It's already written like a fraction for us. So now all we're really doing is simplifying. 63 and 81 both have a factor of 9, right? They both can be divided by 9. So 81 divided by 9 is 9, and 63 divided by 9 is 7. We have an r and an r squared, so this just becomes r. And we have s squared and s to the fourth, so this becomes s to the second. So our ratio will be 7r to 9s squared. It's really just practice of what you did before, but now instead of just calling it reducing fractions, we're calling it simplifying ratios. Okay, so then there's two more examples that are slightly trickier, but I still think that you guys can get them. And this is actually really useful for physics. So when you guys get to physics one day, physics, chemistry, you'll be doing this kind of thing. So we have 45 minutes to 3 hours. Okay, so we have 45 minutes, and this is written in our colon ratio, so let's write it as a fraction. 45 minutes to 3 hours. So you might be just tempted to, say 3 goes into 45, is it 15 times? And it's 15 over 1. But we have a little bit of a problem because we have hours and minutes. So this is where ratios can really be helpful. And I wish actually our book had some more details about this, because what we need to do is we need to get these into the same unit of measurement. Okay, so what we can do is we can say, oh, well, I know that minutes and hours, but I know that 1 hour 60 minutes. Right? And if I multiply 1 hour by 60 minutes, I can cross off my minutes and I can cross off my hours, and I'm left over with 45 over 3 times 60. Okay, so if I do some simplifying, I'm going to get 45 over 180. And I actually don't have this right in front of me, so let me look. Let's see if, I don't believe 45 goes into 180. Oh, it does. 45 goes into 184 times. So 1 to 4 ratio, or 1 to 4 ratio. So you'll notice when we simplify, we got rid of all those units, right? With these problems, you can kind of look and say, does that seem right? And that does seem right, right? We have 45 minutes to 3 hours. So it takes, for every 1 45-minute period, that's equivalent to 4 sections that are 45 minutes each. Okay, so one more example. Jake and Sophia, this one's for you, right? The ratio of wins to losses for a soccer team. So what this is we want to try to write a ratio. Okay, so we want to write a ratio of wins to losses for a soccer team that has played 42 games and had 24 wins. Right? So what the ratio we're looking for is wins to losses. Wins to losses. All right. We know that we've had 24 wins And hopefully we've had less losses than that, right? And they've played 42 games. So I don't know how many losses I've had, but I know that if I've won 24 times, and I assume that I don't tie at all, that means that I've had 42 total games. 24 of them have been wins. And if I subtract, I get 18 losses. Again, this is assuming no ties, right? So 24 to 18. So we can simplify. These both have a factor of 6. So we could rewrite this as 4 to 3. So our ratio of wins to losses is 4 to 3. So that means for every time that, like if we play 7 games, then we should win on average 4 and lose 3 of those games. Okay, if we play 14 games, we would win 8 and lose 6. All right, so that is ratios. I think the assignment for that is to do, let me scroll over here if I can find my mouse. The assignment for that is 1 through 25 odd. Okay, and then the next thing we're going to do is 7.2. It's called proportions. So proportions are just like ratios, except we're comparing 2 ratios to each other. All right, so you can see this written here. Proportion says an equation where 2 ratios are equal. So for this example, we have 2 is to 4 as 4 is to 8. 2 is to 4 as 4 is to 8. So these proportions, sometimes you'll see these as analogies, right? Red is to apple as yellow is to banana. That would be an analogy that you might see. But we're going to use proportions in math to say that this is 2 ratios that equal to each other. So this is a ratio, and they equal each other. We have a ratio that's equal to another ratio. That is called a proportion. And these are actually super useful. I know that right now I'm teaching geometry, and we use proportions in geometry, and I teach Algebra II, and we use proportions in Algebra II. So proportions are really helpful in scaling items and that kind of thing. All right. Now, there is one, a lot of you may have seen proportions before. There's one technique or one feature of proportions that make them super useful. So I'm going to write it over here, even though it's written on this note. So if you have A over B, my ratio of A to B is equal to my ratio of B to C, then we can use something called cross multiplying, or the butterfly. There's lots of different names. And we can say that if I multiply A times C, that equals, oh, I totally messed up my letters here, guys. Sorry, D, and this should be C. A times D should be equal to B times C. If the proportion is true, then this should be too. It should be true as well. Okay, and so this is actually really, really useful. Let me clear this off again. When we want to solve a proportion. So you see there's an example down here. Now, if we have x over 3 equals 5 over 12, you may be able to solve this proportion without using the cross product, or I call it the butterfly. So you might be able to use it without using the butterfly technique. If you recognize, oh, well, this has a denominator of 3 and this has a denominator of 12. So to get from 3 to 12, I have to multiply by 4. This is like what we did in section 6.4, I think. And then to get from x to something, I have to multiply by 4. Ooh, x times 4 equals 5. What is that going to be? That's a little bit tricky. So maybe I'll use my cross products. So my cross products look like this. 12 times x equals 3 times 5. So 12x equals 15. And if I want to solve for x, I divide both sides by 12, and I get x equals 15 over 12. And if I simplify that, I get 5 over 4. So if you go back to this original multiply by 4, 5 over 4 times 4 over 1 equals 5. That's not what I needed to do. Equals 5. Okay, so proportions are actually super helpful to solve ratios when we're missing a factor. So let's do these few examples down here, and that will be it. Okay, so we have 3 over 4y, 3 is to 4y, as 5 is to 7. So this is a proportion because we have one ratio that equals another ratio, right? And we can solve this proportion by using our cross products. So we're going to do 3 times 7 equals 5 times 4y times, if I can get there. Okay, so 3 times 7 is 21, and 5 times 4y is 20y. I divide both sides by 20, and I get that y equals 21 over 20. So that would be a complicated one to try to figure out, right? But we can do it. All right, let's do actually another one from your No, let's go ahead and do this next example here. Okay, so we have 3 equals 2 plus 4y divided by 6. So you're like, oh, wait up, this is not a ratio, Mrs. Ross. But it actually is, because remember, we can put any number, keep forgetting to hit brush, any number over 1. Write this as 3 over 1 equals 2 plus 4y over 6. And we can cross multiply, right? 3 times 6 equals, oh, this is really easy, 1 times 2 plus 4y. So 1 times anything is just itself, right? So 3 times 6 is 18 equals 2 plus 4y. Subtract 2 from both sides and you get 16 equals 4y. Divide both sides by 4, and we end up with y equals 4. So y equals 4 in order to make this ratio true. Okay. Let me double check on your homework here. I know I have 2 kind of complicated examples, so I want to make sure. Yep. Okay. So I have 2 more examples here on our paper. And let's see what we end up with these. I think these might be some special cases. All right. So here's where it gets really complicated. This is when you get to your end of your homework because it's 1 through 29 odd. We have 4b plus 6. Sorry, that's a 6 and a b. 4b plus 6, 4b plus 8, and 6 and 8. So we're going to cross multiply to solve for b, right? We have 8 times 4b plus 6 equals 6 times 4b plus 8. Okay, so let's distribute my favorite property, right? 8 times 4b is 32b. 6 times 8 is 48. 6 times 4 is 6 times 8 is 48. All right, kind of ignore this. So let's send our b's to the same side. We're going to subtract 24b from both sides. And 32 minus 24 leaves us with 8b plus 48 equals 48. So now let's subtract 48 from both sides, and we end up with, it's kind of weird, 8b equals 0, or b equals 0. So that's kind of an odd one. So let's go back to our original problem. Well, if I have 0, I'm left with 6 over 6 equals 8 over 8. So for this particular one, b is equal to 0. Okay, I'm going to save the last example because when I do get back, we will go ahead and go over example number 4 and probably some problems from that section. But I think this should be enough to go ahead and get you started, especially on the earlier problems. And I appreciate you guys logging in to listen, and I will see you on Monday. Have a good day. Bye.